Yeah, you can use that. There's also, behind there's a bunch of pens and pencils you can have. Alrighty. So let's get to it. Our first real notes of the semester, guys. Oh my gosh. I got all the way over here and forgot my coffee. Love it. All right, so this is some factoring stuff. We are not going to have a ton of factoring come up in context in this chapter, but I think it's the next one after this where we're going to factor a ton. So we're going to see factoring show up as review a lot because one of the chapters this semester, we're doing a lot of factoring in the midst of other things. So we're going to have a lot of factoring review being coming up. Okay, so that's what this is in the bell work, is factoring. So we're going to do the X in box thing, where we draw our X. We put our A times C at the top, our B goes at the bottom. And that's all, the A, B, and C are all based off of our standard form here, that AX squared plus BX plus C. So A is always with the X squared, B is always with the plain X, and C is always by itself. So my A and my C, we multiply together at the top. So 1 times 15 is 15. And at the bottom goes my B, which is 8. And the reason we use this little frame here is we're looking for a pair of numbers that multiplies to make 15 and adds to make 8. Does anyone see what pair of numbers does that?
5 and 3.
5 and 3. So 5 and 3. What these do is this uncombines the like terms for this variable. It tells us how that splits into two parts because we need it to split into two parts to fill in our box. In this box, we take the whole A term from the equation, the X squared. We take the whole C term from the equation, the 15. We use the X frame to find these two middle values using the middle variable. So we're going to have 5x, 3x. It does not matter if you switch it, you put the 5 up here and the 3 down here, that's not matter. I tend to do them left and right just like I had over here, but that's just a habit of mine. Pulling our factors in columns and rows, and we get factors of x, because that's what's shared between x squared and 5x. What's shared between 3x and 15? 3. I heard it. It was quiet, but it was there. My top row, they share an x, and in the bottom row, they share a 5. This gives us our factors. So we have x plus 3 and x plus 5, and it still equals 0. And they just asked us to factor, like our only instructions were to factor. So we don't need to solve and get all the way down to roots. So this is our fully factored form. This is our answer. And I know you guys did that in the around the room thing we did yesterday, and honestly you guys did awesome on that. I was loving all the questions, all the discussion. Like, it was super awesome. Why does we go through it together? It is the exact same process on the right-hand one. 100%, exact same process. Pick a slightly different color. Boop. The only thing that's different about this one is it has an A value. So when we fill in our X frame and we put our A times C at the top with our B at the bottom, my A is 2 and my C is -6. We wind up with -12 on the top. Whenever we have a negative on the top, one of these is going to be negative. So I need a pair of numbers that multiplies to make negative 12 and adds to make 1, positive 1. What pair could that be? Ooh, what happened on my screen there? Come back. There it is. What multiplies to 12 and has a difference of 1? Yeah. 4 and 3 are a pair of numbers that have a difference of 1. And in order for the sum to be positive, the smaller number needs to be negative. We're going to have 4 and negative 3. So when we go and fill in our box, honestly, this is the place where we have the most difficulties sometimes. I think because we overthink it. Because what we do is we're taking our a term from our equation. So 2x squared. And I use my c term from my equation, that minus 6. The only things that come out of the x frame are these two sideways guys, and they get the middle variable. So we're going to do our 4x and our minus 3x. And I switched them that time so that I didn't always do the same thing. The most common mistake I see on these, especially when we have the a value up here, is that we try and work this 12 in somewhere. It's not a part of it. It's just a tool we use to find these middle pieces. And so then just like last time, we're going to look at columns and rows. We're just going to have to be carefuler. So what is shared between 2x squared and minus 3x? Just an x. What is shared between 4x and negative 6? Not quite 4. 2. What is shared between 2x and 4x? They both have a 2 and an x. And then the last one down here, negative 3 and negative 6. Negative 3. This spot outside will always match the sign of this box here. Same thing here. This spot will always have the same sign. So this is a positive 4, this is a positive 2. This is a negative 3, this is a negative 3. They're always going to match. So our factored form, bless you, is x plus 2 and 2x minus 3. And again, we're just asked to factor. We're not asked to like solve this or find roots or anything else crazy about it. Just put it in factored form. Okay. Like I said, we're going to have factoring review coming up a lot. There will be one on most of the homework worksheets because we're going to have a chapter this semester where we factor multiple times in every question. We're going to be using it a bunch. So we're going to get used to factoring. We need to get used to factoring if we're not. Okay? So we are going to be starting our first chapter of the semester today. And these are our first kind of definitions. I know it's not super easy to see up here. I'm going to change the viewpoint on it. There we go. I'm just trying to zoom it in a little. So what we're going to start with is we're going to start with operations on functions. So we're going to take those equations and those function rules that we have worked with before, and we're going to take two of them and smash them together in different kinds of ways. And so we're going to have a bunch of notation here, and we're going to use these repeatedly today. And we're going to be using kind of substitution to do a lot of stuff today. So what we're going to see is that we'll be given questions that look like this. So it'll say f plus g of x. And what we need to know is that that means to take f of x and add it to g of x. Yeah. So when it says something like f plus g of x, that's how we'd read this is f plus g of x. We're going to take f of x and add it to g of x. This will be what was written on the page. This is the instruction that we're given. This is how we're going to do it. And that's true the whole way down. This will be the instruction that is given on the page. And this is how we do it. This is how we do it. This is how we do it. I know I'm old. That song's old even for me. Okay, so I want you to write these down. I'm just going to zoom in a little bit further so they're a little bit bigger. There we go. Oh, that's good. So we're going to do addition, subtraction, multiplication, and division with our rules today, with our function rules. And these look super complicated. I promise they're not awful. Okay, there's a couple more minutes because I still see a lot of people writing. I know it's a big wall of text. Okay, I promise we'll see these more as we start working through stuff. Because what we're going to do next is I'm going to give you two rules. I'm going to give you an f of x equals, and I'm going to give you a g of x equals, and we're going to do all four of them. So, looks like this. If f of x equals 2x, and g of x equals x plus 2. So, f of x is 2x. Let's make it purple. And I'll do g of x in green. We're going to start with doing f plus g of x. So this very first one, f plus g of x, that means I'm going to take f of x plus g of x. So what we're going to do is we're going to substitute in the values. I know f of x equals 2x. So when we come in here to simplify, instead of writing f of x again, I'm going to write 2x. And then when I'm going to add in g of x, I'm going to write x plus 2. Make this a bigger transition so we can see. I'm going to zoom this in a little bit. I'll make it out that far. So now we have 2x plus x plus 2. Can we simplify this? What can we do to simplify this? Yeah, I've got a 2x and an x here. So how many x's do we have all together? 3x plus 2. So f plus g of x equals 3x plus 2. We're combining them together. So we're going to do the same thing with the minus. When we look down here, when we have f minus g of x, that means we're going to take f of x, which is purple, and we are going to subtract all of g of x. So we're going to need to be really careful with subtraction. But we're going to treat it the exact same way. We're going to substitute it in. Just when I substitute in my subtraction, I'm going to put parentheses around it. So when I substitute these in, my f of x is still 2x. There we go. And then we're going to subtract my g of x. G of x is x plus 2. I put it in parentheses in subtraction because I need to subtract the whole thing, all of g of x. So I need to subtract both of those. So before we get too far into like an answer, what do I need to do to simplify this? Distribute that minus sign. Come over here. I need to distribute, ooh, chunky boy. Not what I meant. There we go. I need to distribute this minus sign. So what we really have here is 2x minus x minus 2. That allows us to drop those parentheses. So we're going to come in and simplify this. 2x minus x leaves us how many x's? 1x. Which you can either write as 1x or as just x. Minus 2. Questions on the adding or subtracting part? Okie dokie. Same process for the multiplication. So when we look down here at our multiplication stuff, f times g of x, we're going to take f of x times, I'm going to draw a little star for times, g of x. This time I'm going to put both functions in parentheses when we write it down. So I'm going to take my 2x times x plus 2. So it's still using substitution here. We're still substituting our values in. But now it's multiplication. What can I do here to simplify this? Yeah, this is a distribution problem. We're going to take 2x times x. What is 2x times x? 2x squared. And then 2x times 2, 4x. And then our last one here, our last operation, division, when it says f divided by g of x, what that means is we're going to take f of x and we're going to put it over g of x. And a lot of times we are not going to have much simplifying we can do. And that's okay. We're still going to practice writing it, because by the end of the semester, you're going to be able to graph these things. They look weird, but we're going to be able to do it. So we're going to practice seeing them and looking at them and what they mean. So we're going to take our f of x, which is 2x, and we are going to put it over our g of x, x plus 2. And we are going to leave it just like that. For the most part, with the division, that's what we're going to do. That's it. Like I said, by the end of the semester, we're going to be able to work with these and play with these, and you're going to be able to graph things like this. They look weird, but we're going to be able to do it. Okay, so it lets us see them right now without us being scared of, oh gosh, that's too much stuff. Okay, so we're just going to write them and leave them be so that we're not scared looking at them later. Okay, so we have done all 4 of our basic operations with f and g of x. Questions? Because we won't try it again if we don't got questions. We're going to try it again even if we do have questions, but no matter. Okay, because we won't always have just straight up linear equations. Sometimes they get a little wild. So we have a new f of x and a new g of x. So I'm going to change my color since we got new functions. I'm going to do, ooh, that's pretty. We're going to do kind of a tealy blue. So my f of x is x squared plus 3x plus 1. And my g of x, we'll do lilac. 2x squared minus 5. And we're doing those same 4 operations. So we're going to do f plus g of x first. That means I want f of x plus g of x. So we're going to substitute our values in. X squared plus 3x plus 1 plus my g of x, which is 2x squared minus 5. And we are going to simplify by combining our like terms. So I've got an x squared, ooh, way too thick. An x squared plus 2x squared, 3x squareds. I just have a 3x, so we're going to bring over our plus 3x, and then I have plus 1 minus 5, minus 4. And that's our answer for f plus g of x. So this feels a lot more like that polynomial addition and subtraction that we did right at the end of first semester. Same kind of vibe. It's the very same vibe, just in a different font. So same kind of thing down here on my f of x, f minus g of x. That means I'm going to take f of x and subtract g of x. Doing them, they're two separate functions. So when we set that up, we're going to write it out. My x, come on, Ben, there we go, squared plus 3x plus 1. And this time I'm going to put my g of x in my parentheses because we're subtracting all of g of x, 2x squared minus 5. The fact that I am subtracting all of g of x is important. So you got to make sure we subtract the whole thing. I'm going to change the view again. I don't like it out that far. I think that makes it easier to see. So then we need to distribute that minus sign so that we can actually do stuff with it. So I'm going to take this minus sign, that is not a new color, and we're going to distribute it over here, which is going to give me a couple of different. There we go, just so I can have the right amount of space. So we're going to have our x squared plus 3x plus 1. And we're going to take away minus 2x squared. And then what's going to happen with the 5? Is it going to be minus 5 or plus 5? Plus 5. Negative times a negative is a positive. So we distribute that minus sign through. And then we're ready to rock and roll. Combining those like terms together, I have x squared minus 2x squared. How many x squareds do we have? Negative 1x squared, or minus x squared. I don't care if you put the number in front, either way it's fine. The 3x is all by itself right here. And then I have plus 1 plus 5. So we get plus 6. Sorry, there we go. Okay, so then we're going to set up the multiplication one. Zooming it again so we can actually see. We're going to do our f of x. Oh my gosh, come on, pen. Here we go. Times g of x. And yes, we are going to multiply the whole thing out. So we're going to take our x squared plus 3x plus 1. And we're going to times that by 2x squared minus 5. So we're setting them up as a multiplication. And then this is a distribution, or you can do a 2 by 3 box. Either way, we just need to make sure we're kind of staying organized. And I'm going to use some of the space down below because the division, we're just going to write it out and we'll call it good. So, let me grab a color, let's see. We're going to take our x squared times our 2x squared. What is x squared times 2x squared? 2x to the what? 4th. X squared times x squared means we have 4 x's right there. Add your exponents together. So then I'm going to have x squared times minus 5. Minus 5x squared. So then we're going to do our 3x times 2x squared. Close. Close. What's 3 times 3? 6. X to the 3rd. You both had the cubed, but we got to watch out for that 6. Then we're going to take our 3x, I'm going to go down the bottom this time, times minus 5, minus 15x. Then I'm going to have the 1 times 2x squared. That one we're well aware of. 2x squared. And we're going to have 1 times minus 5 minus 5. So they get really, really arrowy here when we do these big multiplications with the polynomials. All we need to do here to get to our final solution is to put them in the proper order. And I only have one pair of like terms we can combine. I have an x squared here and an x squared here. Other than that, it's putting them into standard form. We go from biggest to smallest exponent. We order them by degree. So my biggest exponent is my x to the 4th. So 2x to the 4th is my first term. Biggest to smallest exponents. My next biggest term is my x cubed. I only have one of those, so I'm just going to bring her over. Plus 6x cubed. The next smallest piece is my x squareds. How many x squareds do we have? I say we have this 2 over here. I would say we also have this minus 5 over here. So all together we have minus 3. My only term with just x's is this guy right here. So we have minus 15x. And then that minus 5 is just tagging along at the end. The multiplication ones are probably going to be the ones that take the longest when they have polynomials like this. The division will be the shortest because we're just going to write it out and call it good. Questions on the multiplication one? Okay, let's do the last one, the division, and then we'll talk homework because we don't have time to do a whole nother set. I don't want to go halfway. All right, so when we have f divided by g of x, what that means is I'm going to take f of x and divide it by g of x. So we're just going to write them out, substitute it in together. So my f of x is that x squared plus 3x plus 1. And my g of x is my 2x squared minus 5. And that's going to be where we leave it. We're not going to do anything with it. The only time at this point we'll ever be able to like really simplify it is if our g of x is just a number. Or nobody has any addition and they're all just monomials. If they're all monomials, we can simplify. But if there is any adding and subtracting in either one of them, we cannot do it. Yet. Hint. We will eventually, but not today. Okay. So, I'm going to pass out your first homework of the semester. And it is 6-1. I have it on a worksheet. You can, again, also do it on the digital homework if you like that. If you want to do it on the computer, that's fine. It will also tell you if you are right or wrong. Okay, so the first page is what we did today. What we're going to do tomorrow is what's on the back. So the back stuff looks really different. Okay, I will almost always give you guys at least 2 days for the homework because I don't want to use that much paper and that's a lot of homework. Okay, so the front side is what we did today, so you guys can do the whole front. The back is what we're going to do tomorrow. So you guys have about 5 minutes. You guys could probably do one set. All right, and then have the other 2 as either homework or in classwork tomorrow or whatever. All right, so announcements are going to start in about 5 minutes. Yeah, good job, guys.